What's up, guys and girls? Gribstar here. You don't normally get to hear my voice on these YouTube videos, but I thought I would jump out of the shadows, so to speak. I'm here, sat in the cockpit of the F-16 Viper, and I've not really learned much about this plane. As most of you know from YouTube, I am a Hornet pilot, F-18. I know a lot about that plane, or more than your average person anyway. Certainly not as much as some of the more seasoned YouTubers, but I'm attempting to learn the F-16 now. There's a couple of good campaigns coming out for this, and the plane is fairly feature complete, so I'm going to give it a shot. Let's see how the startup procedure tutorial goes.
Welcome to this training lesson on starting up the Viper. In some missions, you will find yourself in a cold and dark Viper that you'll need to bring to life. While this can be a rather long process described in manual, you can also enable the auto start function. However, for this lesson, we'll review the full startup procedure. Press spacebar when you're ready to get started.
So, as Wags there, the narrator, call him a narrator. The narrator described this is the full startup procedure. So what it goes through is a lot of the test procedures, etc., that you would need to do in a real Hornet if you were starting it up. Not Hornet, sorry, I'm going to use the Hornet. A real Viper if you were starting it up. So there's things like checking certain systems are actually working properly. As this is a simulated F-16, a lot of that's probably not relevant, and you could start the plane up much quicker. But we're following through the procedure properly this time. I'll do a quick start sometime in the future when I've learned it.
As we go, remember a right click generally positions the switch up, while a left click positions the switch down. First, position the main power switch to battery with a click of the right mouse button. This connects the aircraft's battery to essential systems and provides power needed for engine ignition.
So just to describe what's going on here, I'm controlling the camera with my head. That's my head looking around. I've got my hand on my mouse, and you can probably see the cursor moving around there. To me, the cursor's quite bright, but I think when it records, it's really dark, so apologies. When it's over some of this darker stuff, you're not going to be able to see what's going on. I haven't really found a way to make my system record the mouse really bright, so bear with me if you can't see that. Right, what's he asking me to do? He's asking me to switch the main power switch to battery. It's over here, main power switch.
Just below battery. The switch on the same panel, verify the amber Flickus relay light is illuminated. This is a check that the flight control computer's fault monitoring system is operating. Press spacebar to continue.
It's the Flickus relay light there. Spacebar to continue.
Now, position the Flickus power test switch to the test position and hold it in place with the right mouse button. The 4 Flickus power lights next to the switch should illuminate. Returning to the electrical panel, the Flickus relay lights we're just looking at should turn off, and the TO Flickus and Flickus PMG lights should be on. This test verifies operation of flight control computer with aircraft battery as the power source. Release the switch and press spacebar to continue.
So, as you just said, the Flickus is the flight control system. I'm going to put that to test. All 4 lights come on. Get back to normal. And we're going to continue.
Next, position the main power switch to main power. This prepares the aircraft to run off the engine-mounted generator, but electrical power is not available until the engine is up and running. For that reason, the engine and hydraulic oil pressure warning lights on the right eyebrow and electrical system and secondary caution lights on the caution panel should be illuminated. Press spacebar to continue.
So when he refers to the eyebrow, so the F-16 has a number of displays. The eyebrows are these 2 bits either side of the heads up and the upfront computer. So that's the right eyebrow. They're all illuminated. Canopy warning, hydraulics and oil, etc. And the electrical system down there on the caution panel. I think it's the caution panel. Caution lights, yep.
On the EPU panel that is just outboard of the main power switch, you'll want to verify the EPU generator and EPU PMG lights are off. Illumination of either indicates criteria for EPU activation are met. The EPU could activate and create hazardous conditions if the EPU safety pin is removed by the ground crew. Turn the main power switch to off and abort the aircraft if the lights are on, although this is highly unlikely as you have gone terribly astray in the procedure already. Press spacebar to continue.
Yeah, so things he's talking about there won't really happen in a simulator unless you've made some serious mistakes. In a real plane, they could happen if there are electrical faults, etc. But for now, not really concerned.
Now, let's close the canopy in preparation for engine start. This can be delayed until taxi if you wish, but we will close it now to cut down on noise. Use keyboard command left Control C to close the canopy. When it's fully closed, click the yellow canopy handle to lock it in place. Verify the canopy warning light on the right eyebrow goes out. Press spacebar to continue.
I have to say, canopy closing when you're in virtual reality is awesome. You just don't get the same feeling on a flat 2D screen, but in 3D virtual reality, you can actually see the glass kind of reflecting, and you get real depth perception. Right, I'm just going to lock the canopy shut now. There we go. Oh, nice.
Now it's time to get the engine up and running. This can go quickly, so feel free to restart the mission at any point if there's something you want to watch more closely. First, position the JFS switch to start 2 with a left click.
JFS, jet fuel system, start 2, so that's down there.
That just expended both jet fuel starter, JFS, accumulator bottles and began to spool up the JFS. This also closed the Flickus relays and applied power to the Flickus. The JFS run light should come on when it's up to speed and engine RPM should start to increase. Now let's monitor the engine instruments. At 20% RPM, advance the throttle to idle position, right shift, and home. This provides power to the engine igniters and starts fuel flow. You should note airframe vibration and an increase in the fan turbine engine inlet temperature as RPM increases. Monitor those on the right side of the instrument panel as the engine start cycle continues. The secondary caution light goes out at 20% RPM and the JFS automatically shuts off at 55%. The JFS light should go out and the JFS switch should return to the off position automatically. At 60% RPM, the standby generator comes online and the engine warning light goes out. A few seconds later, the main generator comes online and the standby generator goes offline. All aircraft systems are now running off electricity from the generator and are ready to be powered up. Normal indications after engine start are hydraulic and oil warning lights off, fuel flow between 700 and 1700 pounds per hour, oil pressure 15 psi minimum, nozzle position greater than 94%, RPM 62 to 80%, F-tip 650 C or less, and hydraulic pressure for A and B between 2850 and 3250 psi. Verify those on the instrument panel and press spacebar to continue.
Looking good.
Now that power is provided by the generator, we have 3 quick tests to run on the master test panel. Position the probe heat switch to probe heat. Verify the probe heat caution light on the caution light panel is off. Illumination means one or more probe heaters are inoperative or failure of the monitoring system has occurred. Now position the probe heat switch to test. The probe heat caution light should flash 3 to 5 times per second. The probe heat monitoring system is inoperative if this does not occur. Return the probe heat switch to the off position. Press spacebar to continue.
That's flashing, so it's good.
Next, depress the fire and overheat detect button. Verify that the engine fire warning light and the overheat caution light are illuminated when the button is pushed. This checks for continuity of the fire and overheat detection loops. Press spacebar to continue.
Overheat, engine fire, that's all working. Like I say, generally in this simulation you don't need to do any of this stuff. You can start this aircraft up much more quickly. You don't need to do a lot of the tests, but we're doing it now for the sake of accurate simulation.
Then, depress the malfunction indicator lights button. All cockpit warning, caution, and indicator lights should illuminate when the button is depressed. Voice message system audio alerts should play in priority sequence. A brief landing gear warning horn should be heard prior to the warning and caution words. Press spacebar to continue.
So pressing this button will test the functionality of all of our warnings, so it might be noisy.
Pull up. Altitude. Warning. Jammer. Counter. Chat flare.
Yep, we
Low.
are lit up like a
Out.
Christmas tree.
Block. Caution. Bingo. Beta. ISS.
If any of that happens where you're actually flying the plane, you need to consider ejecting.
Now it's time to get our systems up and running and start the INS alignment. This is far easier than it sounds. First, turn on all the switches on the avionics power panel. Each switch in sequence provides power to the modular mission computer, or MMC, power to the store stations, or ST-STA, power to the two MFDs, power to the upfront controls, or UFC, power to the GPS receiver, and power to the data link, or DL. There's also a map power switch, but this is not used in the Block 50 Viper. Press spacebar to continue. Next, position the EGI INS knob to align. This begins alignment of the EGI INS ring laser gyro navigation system. A normal alignment takes approximately 4 minutes to accomplish if the aircraft remains stationary. The knob should be set to nav prior to taxi. Press spacebar to continue. While the INS is busy aligning, we'll complete the rest of the cockpit setup and checks. First, set the CNI knob to the UFC position. This enables control of the primary communications, navigation, and identification functions from the upfront controls. Check that all three wheels down lights are illuminated green. This confirms that the landing gear is down and locked, and the micro switches that sense their position are working properly. While you're there, cycle the speed brakes open, left shift B, and back closed, left control B, using the switch on the throttle. Confirm this visually and monitor the speed brake indicator. Press spacebar to continue.
So that's the speed brake indicator there. Closed, open, closed. And the 3 gear lights are green.
Next, uncage the standby ADI on the instrument panel. This can be done by rotating the knob until the aircraft symbol is aligned with the horizon. Press spacebar to continue.
It's the ADI. So when I turn this, we should be able to get this artificial horizon level with the wings. These are generally only used if the rest of your instruments are either not reliable or kind of failing in some way. I very rarely look at the ADI because you've normally got your heads-up display.
On the sensor power panel, turn on these 3 switches. Right hardpoint switch, on if the targeting pod is installed, FCR switch to FCR, radar altimeter switch to radar altimeter. Radar and radar altimeter transmissions are inhibited until the aircraft becomes airborne, but activation of these systems may be delayed until just before takeoff. Press spacebar to continue. Now we're down to a series of checks that may be run to verify proper operation of the aircraft systems. We will start with the check of the engine operation in the secondary engine control mode. This mode is selected in the case of a failure of the engine-mounted digital computer that controls scheduling of the engine fuel flow. First, raise the switch guard and position the engine control switch to SEC. Verify the SEC caution light is on and engine RPM is stabilized. RPM may drop up to 10% from the PRI value before stabilizing. Stabilized SEC idle RPM may be up to 5% lower than in PRI. Press spacebar to continue.
Yeah, well, when I switched that to SEC, you heard the RPM drop. I'll put it back to PRI. Yeah, they go back up again. There you go. RPM drops right down. SEC caution light should be on.
Now hold down the wheel brake to the next part so your aircraft does not move. Snap the throttle to mill and then back to idle when engine RPM reaches 85%. Check for normal indications and smooth operation. The nozzle position should be 5% or less within 30 seconds after selecting SEC. Press spacebar to continue.
Right, okay, so under my desk I've got some pedals, so they control the rudder and the nose wheel steering. That's me pushing them in left and right. They also kind of tilt forward like an accelerator and brake on a car. When they're both forward like that, that's the wheel brakes are on. So it wants me to hold down the wheel brakes and accelerate the throttle to military power and back to idle when it reaches 85%. So engine RPM up it back 5% or less within 30 seconds after selecting SEC. 5% or less. Nozzle position, right, okay. Yep, nozzle position up there. All good. All good, all good.
Now, set the engine control switch back to pry and lower the switch guard. Check the SEC light goes out and nozzle position returns to greater than 94%. Press spacebar to continue.
There we go, that's back. SEC lights out.
Next, we'll run a check of the Flickus. Start by cycling all your flight controls. Maximum stick inputs warm hydraulic fluid and remove air bubbles, making test failures less likely. Then, position the Flickus bit switch to bit. The run light on the flight control panel illuminates. After a successful completion of the bit, approximately 45 seconds later, the run light goes off, the bit switch returns to off, and the fail light and the Flickus warning light remains off. A bit pass message appears on the Flickus MFD page. Other tasks may be completed while the Flickus bit runs. Press spacebar to continue. Now we'll test a fuel quantity indicating system. You will do this by checking the state of the fuel quantity indicator with the fuel quantity knob in the different positions. Start by positioning the fuel quantity knob to test. On the fuel quantity indicator, the FRAL pointer should indicate 2,000 plus or minus 100 pounds, and totalizer should indicate 6,000 plus or minus 100 pounds. The forward and aft low fuel caution lights should illuminate. The quantity readouts in the other positions should match the aircraft's actual fuel load. After the check is complete, set the fuel quantity knob back to the norm. Press spacebar to continue.
Going to cycle it to test. Fuel quantity over there. There we go. Release test. Looks good.
Next, let's check the operation of the digital backup software. It is used if problems arise with the primary Flickus software. First, position the digital backup switch to backup. Verify that DBU on warning light illuminates and operate your controls. All surfaces should respond normally. Next, return the digital backup switch to off. Verify the DBU on warning light goes off. Press spacebar to continue.
That's the DBU, okay. All good.
Now we'll verify that the trim system is functioning correctly. Set Trim Autopilot Disconnect switch to disconnect. Use the trim head on your stick to trim at both pitch and roll. There should be no control surface motion and no movement on the trim wheels or indicators. Press spacebar to continue.
Yeah, there we go. So I'm moving the trim switch on the stick right now. You can't see that, but the stick's over there, and on my desk I have a HOTAS, hands-on throttling stick. I'm adjusting the trim and nothing's happening.
Return the trim AP disconnect switch to the norm position. Again, use your trim head on the stick to trim at both pitch and roll. The control surface and trim indicators should move. Center the trim for pitch and roll and use the yaw trim knob to check the center trim for yaw. Press spacebar to continue.
There we go, you can see the nose up, nose down when I'm moving the trim. Pat on the stick, up and down and left and right. moves the roll trim.
Next is to check if the manual pitch override system is working correctly. Start by pushing the stick full forward and holding that position. The horizontal tail should deflect down. Then position the MPO switch to override and hold. Confirm that horizontal tail trailing edges move further down. Release the stick and MPO switch to confirm that the horizontal tail returns to its original position. Press spacebar to continue.
Okay, so if I push down on the stick, you should see, yeah, there you go, see the tail of the plane moves like that. If I pull back, it goes like that. So if I do the trim override switch, hold that down, it should go even further. Yeah, and if I let go, it should return to normal position. Yep, and then let go of the stick. There we go. Yep, perfect.
The last check is of the emergency power unit. This check verifies EPU electrical power is available in case of an emergency. It may be delayed until just before takeoff if desired. First, check EPU fuel quantity reads 95 to 102%. Next, set oxygen to 100%. Then, holding down the brake, increase engine RPM to 10% above normal idle. Press spacebar to continue.
Okay, so that's the switch that increases my oxygen from normal to 100%, but first I need to check the EPU fuel quantity. Reads 95 to 100%. Where is that? That's... There we go. EPU fuel, 100% is the maximum amount. So then I need to set the oxygen level to 100%. There we go. Then I hold down the brakes and increase engine RPM to 10% above idle.
Set the EPU generator test switch to EPU generator and hold it in position. Check the following lights: EPU air light on, EPU generator and EPU PMG lights off, Flickus power lights on, EPU run light on for a minimum of 5 seconds. Press spacebar to continue.
Yep, looks good.
Return the EPU generator test switch to the off position. Return the throttle to idle and set oxygen back to normal. Press spacebar to continue. That's it. You're ready to taxi as soon as your INS alignment is complete and you position the EGI INS knob to nav. Use the time on the ground to set up your avionics systems for the assigned mission. Things to consider include SMS page and profiles, radio channels and frequencies, navigation data, bingo fuel settings, ALO settings, and any other systems applicable to the mission. We will pick up again at this point in the lesson that covers taxi and takeoff. You may use the escape key to exit the mission now or continue to explore the aircraft on your own.
Nice, so I think the aircraft is started up and ready to taxi. I guess those dials there switch the heads-up display on as well, which is nice. It's symbology, brightness, that's fine. So now if I leave on this indicator here, if I press which button is it? That one. Nose wheel steering. Right, that's enabled the pedal rudders to control the wheel on the front of the plane as well. So if I push all the way to the right, it'll turn right. If I push all the way to the left, it'll turn left. I'm going to try and take this thing off. Woo. Full right. Yeah. Oh, nice. I don't know how to fly this thing, but I'm going to give it a shot. The next tutorial lesson will teach me how to properly take it off, but I'm just going to have a blast anyway. Why not? It's the worst that can happen. Pump the brakes a bit. But I do like the F-16. I kind of feel like I'm cheating on my F-18 at the moment though. Don't tell her, guys. Right, let's get ourselves lined up and hit the afterburner and hope for the best. Right, brakes. I'm not sure what flaps configuration needs to be for this thing for liftoff. Maybe maybe it already knows, I'm not sure. I'll learn, but right, for now we're just going to go as we are. Wish me luck. Right, we're going to switch off the nose wheel steering, so we're relying on flaps now to direct us down the runway. Easy back on the stick. Easy back on the stick. Run out of runway. There we go. Gear up, and we are airborne. Woo! Handle on the stick for now till I get a handle on this thing. Might just take us out of afterburner. Full military power. And yes, feels good. To the right. To the left. Shall we take it through the ravine? What do you reckon?
Altitude. Altitude.
Okay, calm down. Oh, this thing is nice. How snappy is it? Should we roll it? Oh, it's fast. I think I'm going to enjoy this. Handles like a dream. Which way are we going, left or right? Let's go right. I really like this plane. So that was the startup procedure. I'm going to learn the proper takeoff procedure because I'm pretty certain that wasn't it, what you just saw. I'm also going to start to learn the weapon systems, the countermeasures, how to use the radar. There's a lot to learn. But for now, this has been Gribstar. Thanks for watching. Fly safe, folks.